Hey, what's up everybody? Christian here with a long overdue update video. Before we jump into the usual pfSense and WireGuard related content, which I'm sure is why you guys are here, I wanted to first just take a few moments and acknowledge a pretty significant milestone here on my YouTube channel. When I started this channel back in October of 2020, I never really expected it to amount to much, let alone over 1,000 subscribers. Now, I know that in the world of YouTube, 1,000 subscribers and 30,000 views is really not all that much. But for me, 1,000 subscribers might as well be 1,000,000 subscribers. So first, I want to thank each and every one of you for joining me here on this journey. And if you're not already subscribed and are interested in pfSense and even networking related content in general, please consider subscribing and joining us here. I've got a lot of really good ideas for future content. I want to start doing live streams to engage with you guys in real time. And of course, continuing on with regular project news related to both the WireGuard package and even pfSense software in general. So make sure to stay tuned for that. For those of you that are just joining us, my name is Christian McDonald, and I am a software engineer here at Netgate working on the pfSense team. And for a little bit of background about myself, I've been deploying and managing networks based on pfSense software for a little over 10 years now. So I've been part of the pfSense community for a little while. We here at Netgate, we are really proud of our vibrant social media and our forum communities. And you guys are literally the bread and butter of why we do what we do here at Netgate. So I want to thank each and every one of you, not only for being part of our little 1,000 subscriber community here on YouTube, but seriously, thank you guys for being part of the broader pfSense community. And if you're not, well, I encourage you to check out the links below in the description. We have a very vibrant community on Reddit. The official Netgate forums are also full of super knowledgeable and willing to help people. So make sure that if you're not there, go ahead and click those links in the description below, because it's just a fantastic place to be if pfSense and networking is your thing. So without further ado, let's talk about pfSense and WireGuard. So one of the things that I want to start doing is I want to start incorporating more pfSense related news and updates in these videos in addition to WireGuard related content. So obviously, working at Netgate, the WireGuard package is one project that I'm involved with, but I'm also involved with other areas of pfSense, both user-facing UI features as well as back-end code. So I've had the privilege of working with lots of different areas of the pfSense code base, really over the last months, even before I started working for Netgate. Everybody here at Netgate has been working incredibly hard over the last several weeks and even months on our next release of pfSense Plus software and even pfSense Community Edition software as well. And I too have been working on some pretty cool stuff. So before we jump into the WireGuard stuff, I want to talk about our next release of pfSense Plus and talk about some of the stuff that's coming down the pipe, and also talk about what happened with pfSense Plus 2109. So that's kind of what I want to start with today in this video, and then we'll jump into the WireGuard news. So, developing the WireGuard package has really sort of forced me to become pretty intimate with the open source pfSense code base. So one of the things that I've been working on in addition to the WireGuard package is not only building new user-facing features, which I'm going to show you in just a few minutes, but also really popping the hood and digging in deep and looking for ways to improve the underlying architecture to better support not only the needs of the WireGuard package, but also the needs of packages in general and even other subsystems of pfSense. The unique architectural and integration requirements of a package like the WireGuard package has been a fantastic sort of case project at illuminating many areas of improving the core code base. So the work that I've been doing on the WireGuard package is definitely starting to sort of trickle over into other areas of the code base, and we're pretty excited about that. So if you've been following the announcements related to pfSense Plus, you probably already know that Netgate is committed to delivering 3 regularly scheduled releases per year, planned for January, May, and September. And as you probably have already noticed, looking at the calendar, September has come and gone, and we haven't yet released our third scheduled release for 2021, which is dubbed 2109. So in the process of preparing for our September release, we decided that we needed to spend some more time on fixes and improving our integration pipelines and our build tooling and our performance validation, and that just squeezing all of that into a September release or even an October release just wasn't going to be compatible with shipping a high quality release. So we have instead been taking this opportunity to work on some pretty exciting things that are slated for 2201 in January. And some of that stuff I can't talk about yet, but in the meantime, I encourage you guys, if you're running pfSense Plus, if you have, one of our appliances, go ahead and, if you can, if you're, not running in a mission critical or production situation, maybe you're running at home and you want to try out some new features, go ahead and update to the 2201 development snapshots. I'm sure you guys know how to do this, but you can do that by clicking on System, going on Update, and over on the right, you can modify your update settings. Actually just go to System Update, and you can change your branch, and you can point your pfSense Plus system at the latest development snapshots, and you can sort of play with some of this stuff early. So I encourage you to do that. Again, there's lots of changes that are coming down the pipe, some of which I can't talk about, but the development snapshots are publicly available, and you can upgrade directly via the GUI, the web configurator. So I encourage you to do that. Again, like I mentioned before, our social media and our forum communities have been and continue to be very instrumental at providing invaluable feedback and helping us to continue to improve and evolve pfSense software. So again, thank you guys if you're testing and if you've provided feedback and bug reports. That stuff really helps not only us but also everybody in our community. So again, thank you for that. So one of the hallmarks for 2109, now 2201, is that we are going to start imaging and shipping all of our appliances with ZFS by default. Yes, even including our little SG1100. If you're not familiar with ZFS, ZFS brings a ton of improvements over the older UFS file system, both in terms of data integrity and, of course, lots of additional flexibility for developing new features, different ways of restoring appliances and installations, all things that we're super excited to build for you guys. Because of the additional configuration and monitoring options available with ZFS, I spent some quality time writing some new backend code that lets us really peek into the ZFS system and grab a ton of useful ZFS-related data and metrics. So part of our ZFS rollout here is I took the stab at writing the first UI bits for our ZFS rollout. So if you're running the latest development snapshots of 2201, you can find a brand new ZFS widget on the dashboard. Now, because ZFS does require backing up and re-imaging your appliance and then restoring your backup, you're likely not going to see much here. The widget is there and you can add it, but if you're not actually running ZFS under the hood, you're not going to see anything. But you can find that widget on the dashboard by clicking the plus icon and finding ZFS and adding the ZFS widget to your dashboard. You can see here that the ZFS widget at a high level displays pool status, but there's some pretty cool stuff in the backend code that I wrote to support this initial UI component in pfSense that I think is pretty interesting. So, obviously ZFS, if you're familiar with it, has tons of storage layout and options for configuring, mirror sets and VDEVs that are sort of akin to, what you might find like in a RAID 5 with striped RAIDs, parity-based RAIDs, and that sort of thing, even though ZFS is completely software-based and frankly far superior than any hardware-based RAID solution. ZFS has lots of different configuration options, and the ZFS widget and also the backend code was designed in such a way that it is completely dynamic and very flexible at being able to display any arbitrary storage layout that you might have. Now, we only have a few appliances, 1U appliances, that have redundant storage options that we sell. But obviously, that's monitoring capabilities that administrators need visibility into. So this initial widget here at a high level shows pool status. But what's really cool is that it also can walk the tree of VDEV types and VDEVs to any arbitrary depth and give you insights into mirror sets and hot spares. And there's really no limitation in the backend code as well as even the widget for other VDEV types like logs or caches or that sort of thing, even though some of those VDEV types are questionably useful for firewalls. However, there's no limitations here at all. So, as we produce and ship different products with different storage layout options, and even when pfSense Plus becomes available for white box installations, which is something that we've promised and we're still actively working on, this widget will be able to accommodate any ZFS storage layout that you might have. There's nothing that needs to be updated already. It's dynamic and it works really, really well. So again, at a high level, the ZFS widget shows information like pool health and the overall storage layout, including the size of the pools, how much storage has been used, how much storage is free. And when you click on this tree, which by the way is a first for pfSense, we actually brought in a new jQuery plugin. It's a tree grid UI plugin element that's a first for pfSense software. This tree is smart enough with the backend code to, again, be able to display any arbitrary ZFS storage layout. So again, right now it shows kind of high-level stuff, health, pool health, and also VDEV health if you drill down into the different VDEV types. This is a 6100 that I'm testing on currently, which only has just the EMC storage on this particular box. So there's only one VDEV, physical VDEV. But if you can imagine that if you had a 1U box, say with 2 drives and a mirror, or 2 drives and a hot spare, that you would see a mirror set under the data type and also an additional type for any hot spares that you might have. So again, there's already icons that have been built into the widget to accommodate those different VDEV types, even though, like I said before, many of them are, their usefulness for a firewall is questionable. But I didn't want to hold back at all, so I picked out icons and made the widget totally dynamic, and it looks at the underlying ZFS system and can build a tree accordingly. Even with multiple pools and multiple VDEV types, it's completely dynamic and it works really, really well. So that is pretty much the ZFS widget. And again, it's totally dynamic. We can walk the zpool VDEV tree to any depth and build a nested tree view accordingly. So this is just our first take on building UI elements to provide insights into the ZFS system. Obviously, your imagination can run wild with lots of neat ideas for how to extend this, like providing the necessary backend glue to build in alerts so that if a particular pool enters a fault condition, that not only is it visible on the dashboard, but it also is wired into the notification system in pfSense and is able to provide trigger email alerts and other types of alerts that are already available in pfSense. So again, this is just our first attempt at some UI bits to provide insights into ZFS, and we think it's absolutely great for our initial ZFS rollout, which you can expect in 2201. So in addition, if you're following along here on the screen, in addition I also took this opportunity to rewrite the disk usage section of the system information widget. So if you're familiar with the system information widget, you probably recognize that there used to be a section here for disk usage. And because of the way that we have sort of changed the file system layout and the different mounts, especially dealing with ZFS, being able to split up different mounts, we can then apply different compression settings and other settings specifically to say a mount that's pertinent to logs or that sort of thing. ZFS gives us a lot of flexibility, and it became pretty clear that with ZFS and all that flexibility, that the disk usage section of the system information widget just wasn't going to scale very well in terms of the UI and nesting different file systems and whatnot. So I took this opportunity to sort of build on the background, the backend code that I wrote for the ZFS widget, take what I learned from that, and I took that opportunity to build an entirely new disk usage widget that is automatically added to your dashboard if you had the system information widget enabled, visible with the disk usage section enabled on both pfSense Plus software as well as pfSense Community Edition. So again, this new widget is added to your dashboard automatically if you had the disk usage section enabled. And this widget is pretty neat. So to give you an idea of what it can do, first of all, we are using the tree grid UI element that we brought in for the ZFS widget. And what's really cool about this is that it is able to display any underlying file system layout, again, in any order, in a ordered nested tree layout. So you can see here that by default, we're looking at the root mount, and then we can expand that, and we can see all of the mount points that are sort of nested underneath the root mount on the system, and we can drill down and we can look at the usage statistics for each mount and get a lot of insight into that. So you can see that on my 6100 here, of course, I'm using ZFS, and we have tons of mounts for logs, for var run, for the caching and whatnot, that each have slightly different requirements in terms of compression and that sort of thing. So again, that was one of the reasons why we decided to take this opportunity to also give some TLC to the system information widget and break out the disk usage component and build a brand new widget around that. If you notice, there is a little wrench icon on this widget, so there are a few things that you can configure. So if we click on that, the first thing that you'll notice is an option to pin specific mounts that you might be interested in. So by default, the disk usage widget only shows the nested file system tree that you can drill down into as needed. But I've also built in the ability to pin specific locations that you might be interested in. So let's say that you were interested in seeing var log and let's say var temp for some reason. You could pin those and click save. And then what you'll see here is that those two mounts are now pinned at the top of the list so that they're always visible even if the tree is collapsed. So that's pretty neat. The other thing that you can do with the widget, if you click on the wrench icon again, is you'll find this option for auto show threshold. So this particular feature here, it is a utilization percentage that if any particular mount exceeds this specified threshold percentage, that mount will automatically be sort of, pinned at the top of the list, transiently, as long as there is a fault condition in place. So if you have no pinned mounts at all, even if a particular mount exceeds this particular utilization threshold, that particular mount will be displayed at the top of the list so that as an administrator, you're never left left in the dark with what's going on with the file system. So if you do have a mount that happens to exceed the 75%, which is the default, and you can disable this too by typing in 0 as the threshold, but any particular amount that exceeds this threshold will automatically be bumped to the top of the list. The icon's a little bit different. It's not a pin. It's an alert icon to signify that this mount is in an impending fault condition. But that works really well, and it's pretty cool. So again, that just sort of soft pins that mount to the top of the list, albeit in an alert condition, to display an impending fault state. And also the progress bars are colored. So when usage is really low, the color is a striped green. And then as the usage increases, I think it's above 75% or 50%, the color changes to yellow. And then within that last, I think 25% or so, it turns red. And just, again, to give you a visual cue into what's going on with the file system on your particular pfSense installation. So again, you can already try these widgets out if you're running the latest development snapshots. The disk usage widget is available both in pfSense Plus software as well as Community Edition. So make sure to go and check it out. And as always, give us feedback on if you find these things useful. Again, we're really pleased with how they turned out. We hope that you're too. But again, we really value your feedback. And again, please let us know if you have any suggestions, things that you might like to see. Much like the ZFS widget, again, you can easily let your imagination run wild with some additional capabilities on top of this. But this was just sort of our initial attempt at improving visibility not only into ZFS, which again we're shipping with 2201, and all of our appliances by default. And we took that opportunity to write a new disk usage widget. So again, give it a shot. Let us know what you think, and we look forward to your feedback there. So in addition to obviously ZFS, which is a hallmark feature of our next release of pfSense Plus software, we also have some significant changes to IPsec for both stability and performance. I want to give a big shout out to Jim Pingle, a colleague here at Netgate, for his work on all the IPsec improvements. And you should, as a kind of a broad, high-level overview of what these improvements bring to the table, you should notice significant improvements to IPsec status page loads, as well as loading of the widget, applying and reloading IPsec configurations, and much more. We found that in certain cases and on certain hardware platforms, especially when you have lots of P1s and P2s configured, the difference in load times in page refreshes and widget reloads can be quite profound. Like, there are cases where if you've had dozens of P1s and P2s on slower hardware, that the reload could take what felt like minutes, and now the page reloads are happening in seconds. So it's that level of improvement. There was lots of back-end code in optimizing routine calls that we were calling pretty liberally too often, and instead we're caching those results and sort of moving them through. So function calls that don't need to be called for every single configuration, every single P1, every single P2, etc. We're calling them once where we can, and then kind of caching those values and passing them kind of through the chain of command when we do things like reload the configuration or refresh or restart services and that sort of thing. So that sort of design philosophy was also something that I adopted with the ZFS widget and the disk usage widget, and wrote some new backend code that actually makes polling the ZFS subsystem and even the file system really efficient. So obviously, disk usage and even the ZFS system, those are systems that are always changing, but they don't change as often and as quickly as one might refresh the UI. So one of the things that we're doing with the ZFS widget and the disk widget is that we actually cache the result, the output of the state of the ZFS system and also the file system, and we use that cache as often as we can, and periodically we will trigger a miss on the cache, and then we'll do that expensive task of actually querying the underlying file system subsystem in ZFS to actually get new data. But what it means is these two widgets are not going to, be a significant impact to, the dashboard reloading. For most of the time, they're really, really fast because we're just feeding off of the cached values, the cached state of those subsystems. But every so often, obviously, that needs to be invalidated, and we pull in new values and update the widgets accordingly. And it's all based on Ajax, so they're wired into the dashboard Ajax loop, and they update automatically. So if you want to play with this and you want to kind of come up with some bash scripts that just fill up your drive, you can sit there on the dashboard and watch the utilization percentage increase. So that's pretty cool. And one of the really interesting features of the tree grid widget, or the tree grid UI element that we pulled in, is that it has the ability to sort of save the state of the tree. So if you, for example, expand the tree, even if the tree is updated via Ajax calls, the tree is not going to collapse, which is really annoying. So sort of my initial sort of proof of concept work when I was working on this, every time the Ajax, would trigger and the tree was rebuilt, even if it was built from cached state, the tree would collapse because it has no way of knowing that the user actually expanded that. But the tree grid jQuery plugin that we're using is actually smart enough to store the state of the tree as a little cookie in the browser, so that in between refreshes of the widget, via Ajax, that the tree will automatically stay in the state that was left by the user. So you can see here that it might not be obvious, but the ZFS widget is updating, every so often via the Ajax loop as well as the disk widget, and the tree is not like arbitrarily collapsing. It's that state is actually saved and is persisted between calls. So again, it's little things like that just really make the usability of this, the widgets just, I think really top notch, and I'm pretty excited about it. But, going back to the IPsec improvements, that concept of caching and passing credentials along without having to, make those expensive calls to subsystems, every single time that value is needed, that kind of paradigm we're starting to use in other places. I used it in the widgets, and Jim incorporated that concept into the new IPsec improvements. And as you can see, the performance gains and the stability gains are quite profound. As always, make sure that you check the official Netgate documentation, especially the upcoming release notes for 2201. The changes to the IPsec subsystem are quite significant, and you might have some situations where you might actually need to tweak the configuration. But the documents, the release notes outline those particular cases. So if you're using IPsec in your environment and you update, make sure to kind of peruse through that probably before you upgrade, so that you're aware of changes that might need to be made, and you should be good to go. So we've been dog fooding the IPsec updates, both internally, and I've been testing them out as well, and it's a really welcome improvement to the IPsec subsystem of pfSense. So we're pretty excited about that. So again, huge shout out to Jim Pingle here at Netgate for all of his work on the IPsec side of the next release. So let's talk about WireGuard. So if you haven't already seen my other videos where I discuss the development of the WireGuard package in detail, I highly encourage you to check those out. I talk about many of the design choices that were made in regards to, converting the original WireGuard implementation that Netgate shipped in 2.5 and 2101 or 2102, that February-March timeframe. So there's a lot of changes from that initial WireGuard implementation to what we have today. And the previous 10 videos or so kind of talks about, sort of why those changes were made, But the TLDR here is that the WireGuard package is rather unique in the pfSense software package repository in that it introduces an entirely new type of pseudo interface. And if you're familiar with the way that pfSense works in terms of like moving configurations between installations or even adding or removing network interfaces, on a particular, box, you're probably aware that pfSense, checks the state of the interfaces and the naming and the configuration consistency at startup. So if you add a NIC or you remove a NIC and that conflicts with what is actually configured in your config.xml, pfSense is going to actually pause the boot up process and prompt you, the administrator, to reconcile those differences. So for example, if you had a network card that, let's say, was, heaven forbid, was using like the Realtek drivers, which we always recommend using Intel, and you upgrade to an Intel card and you pop that in your machine and you restart, pfSense is going to see that, whoa, the network interfaces have changed. It doesn't know what interface is WAN, it doesn't know what interface is LAN or opt whatever. So it's going to prompt you to reconcile those differences and fix that part of the configuration before it starts. Now, for a package that's introducing a new interface class entirely, this can be problematic because if you've configured pfSense to use a WireGuard interface, if you've assigned it in pfSense, that makes that interface a dependency to actually boot pfSense. And if that particular interface is not, available and brought up early enough in the boot up process, pfSense is going to trigger, the wizard to reconfigure and to reconcile, the mismatched interfaces. So this was probably one of the biggest kind of, challenges that I had to work around with developing this package was how do we introduce an entirely new type of interface to pfSense while making it resistant to configuration changes and obviously, restarting pfSense, or what happens if you uninstall the package and you still have a WireGuard tunnel configured as an assigned interface, in pfSense. Those are all situations that could potentially, break a pfSense box, in terms of it not being able to boot correctly. So, the initial work with developing this package was, I wanted to reintroduce WireGuard back into pfSense in a way that required no modification to the core pfSense code. I wanted to use what was already available, what pfSense already provided us, and not have to make modifications to the core code, knowing that, changing core code, outside of the package code just makes, testing and validation and ultimately getting the package out to you guys, that much harder. So thankfully, we were able to make that happen, and we were able to reintroduce the WireGuard package into we were able to reintroduce WireGuard as a package without having to make any modifications to the core pfSense, the core pfSense code base. So again, my previous videos just sort of kind of walk you through that development process and why those changes were made. And ultimately, many of those changes had implications as high as the user interface and how users actually configure WireGuard compared to how WireGuard was configured when it was built into pfSense. I know that this question comes up in social media and in the forum and Reddit and whatnot quite often, and that is, will the WireGuard package ever be reintroduced back into the base pfSense code base? And it seems like people are either totally okay with that or they're not. And I think those that are not okay with that are kind of misinformed about what it means to be a package in the ecosystem of pfSense. Currently the way that the pfSense architecture works is that code that's installed by a package, it lives really side by side with code that's shipped in the core code base with the core product. So this notion that a package somehow is inferior to delivering WireGuard as a core feature is sort of misinformed, and I want to make sure that everybody understands that there are way more advantages at shipping functionality in the pfSense project as packages than it is to build it into the core code base. Other companies like Apple and Google, especially in terms of mobile, like Android and iOS, where applications that used to be part of the core product, like the Mail app and Calendar app, I think, and there's other apps that used to be built in to iOS, are now actually delivered through the App Store. And the reason for that is pretty simple. It allows those parts of the product to be updated at a much quicker cadence than the actual core underlying system. So by shipping the WireGuard functionality as a package, it allows us to iterate really quickly. And this is not only beneficial just in terms of that, but we also have to consider that unlike other VPN technologies like IPsec or OpenVPN that go through these elaborate song and dances to establish cryptography wise to exchange compatible ciphers and different ways of exchanging encrypted packets. IPsec has to work with lots of different types, and OpenVPN has to work with lots of different crypto strategies. WireGuard is really opinionated in that if something is found or there's a change to the crypto that's breaking, both ends of the WireGuard link have to be updated. That's one of the reasons why being able to update WireGuard quicker than actually shipping point releases of the core pfSense code base is really beneficial. So there is currently no push right now to reintroduce the WireGuard package code back into the core code base because it really does provide us a lot of flexibility. And when the WireGuard kernel module code or the userland tools are updated, we can update those without having to ship the big monolith that is the pfSense code base just to update those small little bits of the product. So, if you're concerned about that or sort of feel that, the WireGuard that we have now is inferior to the WireGuard that we had, back in February, March with 2.5 and 2101 or 2, I forget which one it was at the time, don't be alarmed by that. This is actually a really good thing, and it's a lot of flexibility that is going to, it has continued to prove itself useful. So again, it allows us to ship updates a lot quicker, to test them a lot quicker, and without having to think about shipping complete updates to the pfSense software just to make those changes. So that's sort of the high level sort of progress on what the first 10 videos sort of covered. Because of those changes, the documentation that was written for 2.5 and the pfSense Plus release, that documentation has changed. So several weeks ago, I spent some time and updated the documentation to reflect those changes and differences with the package. So I'm going to leave a link in the description below to the updated Netgate documentation for the new WireGuard implementation. Conceptually they're very similar. It's still WireGuard, but some of the ways that things are configured has changed. And again, as a package that can be evolved a lot quicker than anything in the core code, I've taken that opportunity to really experiment and build some pretty cool usability features and options there. So I did spend a lot of quality time in updating the documentation. So if you haven't already checked that out, I'll leave the link in the description so that you can find the updated documentation for the WireGuard package. So again, feel free to let us know what you think about that. If you find any mistakes or anything like that, let us know, and we'll be sure to get that updated in the docs. So, you know, in addition to the work that I have done over the last few months on ZFS and the file system components to pfSense, obviously, you know, that development has introduced, you know, improvements and new UI elements and things that can be used in other areas of pfSense. So one of the things that I'm working on is actually taking the tree grid component that we brought in for the ZFS widget and the disk usage widget and actually build those into the WireGuard package UI code. So both the, you know, the tunnels page as well as the status page, you know, these are great candidates for using that tree grid in a way that actually just makes the user experience just way better. So that's one of the things that I'm currently working on is actually taking, you know, what we've built and what we've learned from other areas and actually then bringing those back into the WireGuard package to benefit that area of the code base as well. So, you know, like I said before, developing the WireGuard package has benefited other areas of pfSense, but then also working on other areas of pfSense is benefiting the WireGuard side of things. So it's really this mutually beneficial exchange of ideas and code that's hopefully making everything better. So I'm really excited about that. So in addition to, you know, UI improvements to the WireGuard package, again, as a result of the changes and updates that are you know, from the ZFS widget and the disk usage widget, there are also tons of little quality of life improvements and bug fixes that have been made over the past month or so that are going to be kind of rolled up into a new package release that will be available soon. I want to give a huge shout out to a member of our community on GitHub, Adam Cooper, for his recent contributions to the package code. You know, as a reminder, Adam contributed the initial work for the WireGuard for the WireGuard widget that we have now. So again, I want to thank him for that. But Adam has more recently, Adam has jumped in and has tackled, you know, several little issues like resolving page flickering caused by, you know, HTML tables being generated and rendered in a visible state prior to jQuery being instantiated and sort of taking control over the DOM and hiding those particular rows and sections and whatnot. So, you know, things like that. Also, you know, new configuration options like peer status visibility on the status page. And he also has contributed improvements to some validation logic surrounding keep alive values and also the peer allowed IPs. So you can expect to find these improvements and fixes in the next release, which again, I'm planning on getting out very, very soon. But once again, I want to thank Adam for being part of our community and contributing code to the WireGuard package project. So in addition to that, I have been investigating a pretty obscure bug with handshakes with remote peers following issues with your WAN connection. So this was a bug that was actually brought to our attention on Redmine by a fellow member of our community, Ryan Rusa. Hopefully I'm pronouncing that correctly. And you know, basically the issue here is if you had a WAN connection that you know was flaky, you know, went up or down, or let's say you had a modem that was rebooted or an upstream issue with your ISP, that there was some condition where pfSense would just cease to exchange handshakes, and the only way to seemingly fix that was actually rebooting pfSense completely. I wasn't able to replicate this issue as clearly as Ryan was. So I want to give a really big shout out to him for, you know, being able to really provide a thorough bug report, and his analysis was phenomenal. So he obviously had an environment where he was able to consistently hit this bug, and not only was he able to consistently hit this bug, but he also had the the insights into digging in deep and kind of proposing and figuring out what the issue was. So not only was he able to, clearly replicate the bug, but he was also able to even write a Band-Aid script, a shell script that was actually able to work around this. So this was something that he whipped up that he was running as a cron, as a kind of a background cron job very frequently, and this particular script was able to work around the problem. Now, because I wasn't able to clearly replicate this in my environment, I can't really talk about whether or not this script actually works. Although I have no reason to not trust Ryan's work. He claims that it works, and it seemed to work for him. I just wasn't able to clearly replicate this issue. But I just want to kind of just acknowledge this type of bug reporting. This is the sort of analysis that is just golden in terms of getting problems solved. Not only being able to consistently demonstrate this issue, but also being able to develop a script that can actually work around the issue. These are hallmarks of just great bug reporting. Now, obviously, Band-Aid scripts are, well, they're just that. They're Band-Aids. They're not ideal for production use. But one of the things that I actually suggested early on was, asking the question, is this particular bug unique to WireGuard in pfSense? And Ryan was actually was able to kind of take that idea and actually test whether or not this particular bug was a thing on other platforms, other FreeBSD products that are using the same WireGuard kernel module code. So he found out that this bug was not unique to pfSense, and the Band-Aid script that he produced, along with him reaching out to sort of the broader WireGuard community on Reddit, actually garnered the attention of other members of our, the broader community, the FreeBSD community, and really helped to narrow in on a potential solution. So, this garnered the attention of a FreeBSD committer, Kyle Evans, who was able to actually track down a possible issue with the WireGuard kernel code as it relates to the internal state machine. And as noted by the commit log for the solution here, it pretty much says that the keep alive timers, both persistent and mandatory, are part of the internal state machine, which needs to be cranked whether or not the packet was actually sent or not. A packet might be dropped by the network, or the packet might be dropped by the local network stack. Anyway, it goes on to some more rationale for what was going on here, or what might be happening. And they also mentioned that the proposed change that Kyle suggested is actually brings the FreeBSD kernel code more in line with what's going on with the Linux implementation as well as the WireGuard Go implementation. So things are looking good that this is actually the fix for this issue. So as soon as the FreeBSD port is updated to include this change, you can be sure that we're going to update our ports tree as well, and we will ship the latest snapshot as an update to the package. Again, another benefit of having the WireGuard implementation in pfSense as a package, because if this was something that we built in to pfSense, to ship a fix like this, we would actually have to ship a point release of the entire monolithic pfSense codebase. So again, this is another example of why shipping pfSense as a package is super useful. So make sure to stay tuned for that. Again, I want to give a big shout out to Ryan for his thorough investigation and reporting, and also to Kyle Evans and Jason for their work in getting a possible solution into the kernel code. So we look forward to testing that here with the pfSense WireGuard implementation. And again, this particular bug has implications that reach far beyond just pfSense. They also impact the FreeBSD community at large. So it's just really neat to to sort of see how all of these individual projects sort of edify each other. And obviously pfSense, we have lots of users using pfSense. Arguably, there's probably way more users using WireGuard on pfSense and other FreeBSD-based networking solutions than actually using them on, vanilla FreeBSD. So, this is really a great test bed for, illuminating potential bugs in the actual underlying FreeBSD kernel code. So, as you know, here at Netgate, we are huge contributors to the open source software movement, and it's just, and you guys love that. In fact, customer surveys, it's consistently at the top of the list of why you guys love pfSense software is because the backend core open code is open source and fully code inspectable, and you guys love that. So it's really awesome to see other people in our communities like Adam, like Ryan, Kyle, Jason, and you guys watching that take interest in not only our projects here at Netgate, but also the projects that we depend on, like the WireGuard kernel module and the user space tools for actually configuring WireGuard, and making contributions in terms of code and also testing and providing feedback. So again, to everybody that's been helping here, either with code contributions or testing or providing feedback, thank you guys. You guys are awesome. And we could not do this without our communities. So just wanted to kind of leave you with that. So, wow, this video is approaching an hour. I had no idea that this would be an hour, but I guess it's sort of, it's been a while since we've had an update video. So I'm going to make sure to put timestamps on this video so it's easily consumable, because I'm sure that there's not a lot of you that are going to sit here and listen to me ramble on for an hour. Maybe, I don't know. That's if you like to listen to me talk for an hour, then that's cool too. But anyway, I think that about wraps up this project update. Again, if you are interested in pfSense and networking related content, I encourage you to subscribe. Make sure to click that bell icon so you don't miss any future videos. Make sure to check out our social media and our forum communities. We have a very vibrant community on Reddit, user group on Facebook, and of course the official Netgate community forum. And as always, I will include links in the video description so that you can easily find your way to those communities. So again, thanks for watching. Make sure to leave comments in the description below. Continue testing and providing feedback, and continue being part of the pfSense community. So again, thanks for watching, and we'll see you next time.